All right, we are live. Fantastic. So we're going to keep an eye on our attendees because they're going to come kind of trickle in here as the technology allows it, I guess. But thank you everyone for who's jumping on right now. We're just going to give it a minute or two just to have everyone get a chance to log on and log in. I know that these days pretty much almost everybody's used Zoom, but you know, there's always an update. There's always something that's, you know, allowing it to be on for a second. So appreciate your patience here. And it looks like a good bunch of people, and that's good. I like to see that. I'm excited for this webinar today. And so for those who are just joining us, this webinar is probably about 45 minutes long. And we are recording it, so anyone who's watching this and they feel would like to see this again or share this with anybody else, they certainly can. I'm going to be capturing this. I'm going to load it to a YouTube channel as well, just so we have a place where you can go back and watch it anytime. For those who feel this is really beneficial to your organization, maybe they want to have this and share this with some other folks in the organization as well. We can, you know, Brad's be willing to do this presentation again for maybe a smaller group within a particular organization. We can certainly do that as a private training. So my name is Ben Reeder. I'm with the RG group, and today I'm really just the tech nerd. So I'm the guy who's putting this webinar together. So I brought a couple experts to the table. So first off, I'd like to introduce Jason Goody, who is with the RG group. And he's going to give us a little backstory and then introduce Brad for us. So
hey, thanks, Ben. Yeah, thanks. Hey, and thank you all for attending today's webinar. It's great. It's great to see everybody on. It's also great to see that we have a few people on today that attended our hydraulic safety webinar we had a few weeks back. And, you know, two very important topics to us at the RG group is, you know, hydraulic safety, knowing what to do, what not to do when working around pressurized fluids to keep, you know, you and those around you safe. And then also the health of your system. Today, we're going to learn about contamination, the impacts on your system, and most importantly, what you can do to prevent it. And also there will be, keep your eye out if you weren't able to attend the previous hydraulic safety session. We will have more coming up in the future, so keep your eye out for that. So to get started, I want to say I'm pleased to be joined today by Brad Satterthwaite from Parker Hannifin. Brad's a territory sales manager for the hydraulic and lube filtration platform within Parker. Brad covers the Northeast region, is based out of Boston, Massachusetts. Has responsibility as far north as Maine and down to Virginia, so probably covers most of the territory for the folks on the call. Brad entered the territory last year in the summer after completing Parker's technical sales development program, where he spent a year learning the industry, the technology, and all the products that he now represents. And before working for Parker, Brad attended the University of Dayton and graduated with a degree in chemical engineering, so he knows what he's talking about. So welcome, Brad.
Yeah, thank you, Jason. Thank you, Ben, as well, for setting it up. Everyone else at the RG group behind the scenes getting this webinar up and running. And also wanted to thank the attendees here for your time to get on and learn a little bit about hydraulic contamination. Hopefully we all learned something today, something we can take back and use in our hydraulic systems. So like Jason said, introduced here, we're going to go through different types of contamination that are present in a hydraulic system. Then we're going to talk about the impacts of those contaminants, where they come from, how to prevent them, how to tell what's wrong with your system, and how to fix your system once there is contamination within it. So before we dive into contamination itself, we really need to understand what hydraulic fluid is used for. So there's four main functions of hydraulic fluid. The first is to act as an energy transmission medium. So this is typically what you think of when you think hydraulic fluid is used for. It takes the energy you're putting into the system through the pumps and the pressure, transmits it through the system, and causes the movement that the system was designed for. But beyond that, hydraulic fluid also lubricates the internal component moving parts within a system. It acts as a heat transfer medium within the system, so pulls away heat from any of the hot points in the system, any place there's friction, disperses it around the system. And it also seals clearances between moving parts to prevent leaks. So if any one of these 4 functions is impaired, the hydraulic system will not perform as designed. From a leaking system to a system that does not have the output that it was designed for, to a whole number of things, hydraulic contamination is the main way to start. It is the main cause of these impaired functions, and it can even be attributed to up to over 75% of the hydraulic and lubrication system failures that we see in the field. So that contamination will get into your system. It'll break down those 4 attributes of hydraulic fluid and can cause some headaches in the field. So when we're talking about contamination, there are 3 main types that can be found in a hydraulic system. The first one is probably the most common, the one everyone's most familiar with. It's particulate, so just hard particles within the system. But there's also water and air contamination that can get into your system and cause problems and interrupt the functions of that hydraulic fluid. So to dive into the particulate contamination, there's 2 different types of particulate contamination. It's broken down into silt and chips. So silt is the small particles within the system. They're typically less than 5 microns in size, and you need to care about those as they build up within the system over time. Those small particles are not going to cause big failures all at once, but if you let them build up, let them kind of conglomerate together, then they can cause some issues. The chips are particles that are greater than 5 microns in size. And those are the ones that as soon as they enter your system, they have the potential to cause immediate catastrophic damage. They can get in between clearances with different components of the system and cause breakdown right away, and are really the ones that we need to filter out and make sure we are keeping out of our systems. So when I said 5 microns in size, that's not really a unit of measurement most people are familiar with. It doesn't show up in daily life. So I wanted to give some real life comparisons for how small that actually is. So when you look at a grain of table salt, that's about 100 microns across. So that's a good 20 times bigger than the particles we care about. The lower limit of human vision is about 40 microns. So that's anything smaller than 40 microns is not visible to the human eye. You'll have no clue it's in there. If you hold up a sample of oil, it'll look perfectly clear. It'll look perfectly clean. But really there could be a ton of stuff smaller than 40 and greater than that 5 micron limit threshold that we care about. And then when you get down to the size of bacteria and red blood cells, that's really the area that we care about within a hydraulic system. So that 5 microns is right in between those. It's not going to be visible to anyone, even the best vision among us. So that's really what you need to look out for. It's not going to be easy to diagnose when you take a sample, but it will still be present in the system. When we talk about contamination, we first need to understand where it comes from. So there's a couple main different types and sources of contamination. The first one being built-in contamination. Whenever you're building a hydraulic system, you'll be cutting hoses. There'll be seals going in that can generate rubber particulate if it's left in the system. If the system was built and then kind of sat around the shop before being put in service, it can gather dust or welding slag if that's present in the environment. And different parts can have sand from castings in them, just depending on how they were manufactured. That's another place where they can just be built into the system. May not have done anything wrong. It is what it is that's present when you build it, and it's part of the building process of a hydraulic system. There's also externally generated contamination. So depending on the environment, there can be a wide range of ingression rates for your hydraulic system. These numbers you see here are for particles greater than 10 microns in size. So that's even bigger than the threshold that we really need to look at when we're talking about particulate contamination. But even in the cleanest of clean assembly facilities, you can be pulling in over 100,000 particles per minute into your hydraulic system as the fluid in the reservoir rises and falls. So that's just something to keep an eye out for. You may think that the assembly facility you're in is perfectly clean. How could any particulate be in the air? But again, it's the really, really small particles that you can't see. You really don't even know they're there, but they're going into that system at a high rate. If you're in a dirty environment, like on a mobile equipment, construction equipment, something like that, you could even be pulling into up to 10 billion particles per minute. So this just really puts into perspective. You may think that there's no way anything's entering the system, but you can have some extreme rates of particulate being pulled in. Going into generated contamination. So even if you're not pulling as much in, you're doing everything right there, you can be generating contamination within your system. The kind of the main ones to look out for here, abrasive wear is when a hard particle bridges two moving surfaces, that can scrape away material on one or both sides of those surfaces, and that generates more particulate. And in turn, that particulate that was just generated can generate more and more and more particulate. It builds on itself as it goes. Another source of generated contamination is through erosive wear. So that silt or those fine particles, if they're in a high speed stream of fluid under high pressure, they can run through your system and break down edges or surfaces within the system. So the best way to picture this is if you have a bend in your system, all of those particles are going to be flying through the fluid. And as soon as it hits that bend, they're going to slam into the end of the pipe. When it does that, it's going to break away little pieces every single time. So over time, it continues to build on itself. It'll continue to get worse and worse and worse until you do have those chip particulate that can cause major problems in a system. Some of these other ones here are common in systems. Those are kind of the two that I wanted to highlight. Those are the ones that are most present in systems and are really hard to even prevent or get rid of. But there's something to keep an eye out for and know that if you do have contamination, especially particulate contamination, it'll continue to build on itself and continue to get worse and worse unless you do something to prevent that. And finally, one last source of particulate contamination that I wanted to present here today is contamination from new fluid. So most hydraulic fluid on the market is not clean enough for the systems that customers and end users are running today. So if we start with product C here on the right, you can see by this picture, there's a lot of particulates, a lot of bumps, even these big dark circles here. You can tell that there's a lot of contamination. If you're familiar with ISO codes, this is a 252421 ISO code. That's just the cleanliness code used for hydraulic fluid. And that's way dirtier than most common systems need. So this is just straight out of a bucket, already way dirtier than it should be. Moving to product B, you can see it's a little bit better, but it's still not great. There's still a ton of these little dark circles, little dark bumps, and that's contamination within that system. If you move over to the left one here, this is actually a Parker product. It's a DuraClean. It's packaged as a clean fluid. So it is clean enough for the common systems today. And if you just look at the difference between these two boxes, the normal ones on the market, typical oil that you see and use on a daily basis, doesn't come clean. So it needs to be pre-filtered before entering the system. And another point I wanted to bring up here on this slide is the color of the oil. So all three of these are brand new oil, straight out of a 5-gallon pail, and then taken a picture and tested. So as you can tell, the color of the oil really doesn't trend with the cleanliness of the oil. You may think this middle one here, since it's the lightest color, would be the cleanest. But most manufacturers add different dyes, different coloring to their oil to get it to kind of look how they want it to when it comes out of the pail. So as you can tell, this really dirty one, it is the dirtiest oil, but you would guess this next one would be kind of second dirtiest, but it's a lot cleaner than some of the others. So just visually inspecting oil, both because of the small particulate that is impossible to see by the human eye and by the color, is not a good way to diagnose what is wrong with the system. So going down into what actually happens when you have particulate contamination. So as you get particulate contamination, it builds up over time. You get bigger and bigger particles in the system. You can increase the component replacement costs. So that particulate can break down different components within the system, cause increased maintenance to replace those, increased costs just to buy those new parts. And all that together can increase your loss of production or increase your downtime for your system. That obviously costs money as well. You're not able to produce, you're not able to use that equipment while it is getting fixed. And it really does just cause a bunch of headaches just because of these little tiny particles in the system that you can't even see. On top of that, there's frequent fluid replacement, which can be very expensive, just to drain out all of the oil, replace it with new clean fluid. But then on top of that, you have to dispose of the old fluid, and that can be 3 to 4 times as costly as the normal, buying the new fluid is. And just wanted to point out here, the function of a hydraulic filter is to clean the oil, but really you need filters to reduce the operating costs. So reducing that downtime, reducing the maintenance to keep your system running. That's what a filter is used for. It does clean the oil, but really what you care about is keeping the system up and running at a healthy rate. And so to prevent particulate contamination, there's a couple things you can do to prevent all those effects of it. The first one being utilizing reservoir air breathers. So those ingression rates I said before, instead of just pulling in the dirty air straight into the system, you can use an air breather to filter out that oil, capture as much of that particulate as possible before it enters your system. You can flush systems before initial startup so that built-in contamination can be minimized. You can flush it all out. Hopefully it'll be as clean as possible before you actually start up and get up to pressure. You can specify rod wipers and replace worn actuator seals. Those are essentially just seals to keep the outside environment on the outside of the system, rather than pulling in any dirt that may have generated or may have accumulated on the exposed pieces of the system. You can also cap off hoses and manifolds. So anytime you take a hose off of the system and you just have an opening that's open to the environment, capping it off as soon as possible can decrease the amount of particulate that enters the system. And like I said, you can pre-filter all new fluids. So you don't want to get a new gallon of oil and just dump it straight in. You're introducing a whole bunch of dirt when you buy that new oil. And some warning signals. So how do you actually know that particulate contamination might be a problem? How do you know that this is something you need to worry about? The couple of the main common ones are valve spool decentering. You may have leakage or chattering in that valve spool. You may have pump failure, you may lose some flow, or just even be just replacing the pump more frequently than you should. So over time, that particulate's going to eat away at the pump. It's going to cause it to fail prematurely. You'll just be changing out that pump way more often than you need it to. You can also have cylinder leakage and scoring. So if you look at the picture here, you can see some pretty severe scoring on the cylinder. If any particulate gets trapped between the cylinder and the chamber there, it can just scrape away, and that, like I said, builds on top of itself. So once you get a little bit, it'll continue to wear down until you get to a situation like this. And then you can also have increased servo hysteresis. These are just some main warning signals to look out for. If your system has any or all of these, particulate contamination is a great place to start looking. If we connect it back to the 75% of hydraulic system failures can be linked to contamination, a lot of these don't look like contamination right off the bat. You may think something's wrong with the pump. You may think something's wrong with the valve spool, but all of it can be traced back to contamination rather than the actual component itself. So what you need to look for now, how do you actually know how bad the particulate contamination is? How do you know you have it? So different equipment has recommended fluid cleanliness standards. So you need to verify that your filtration currently on the system is performing as it needs to. And you also should be knowing what you're putting into the system. So if you test that new oil and you know it's clean when you're putting it in, you know you're not dumping a whole bunch of dirt into the system. And it even goes back to the new equipment. Today's standards a lot of times has fluid cleanliness levels connected to the warranty of that equipment. So if you're using fluid in your system that is dirtier than the manufacturer recommends, that could void warranty. It could cause that equipment to break down a lot quicker than expected. So how do you actually do this? On the market, there's a variety of particle detector products. So it'll basically shine a laser onto the fluid and tell you how dirty it is using the shadows of the particulates. You can also have lab testing. It'll tell you exactly what is in the fluid from the type of metal to the water content, to really the size of the particles. Anything you may need can be all accomplished by that lab testing. And really the how kind of varies by application, by fluid and data requirements. So the lab testing is obviously going to be a lot more in depth than something you can do on site, but really just depends what you're looking for, depends what information you need to get from your system. So that's something that myself or the RG group, or really anyone on this call here from the RG group could answer, could get you connected, and we could figure out the best way for you. So once you know you have excessive particulate contamination, you've done the particle detector, you know what your ISO code, your fluid cleanliness is, and you realize you need to make it cleaner. The best way to start really is to look at the current filtration and see what you have there. So you can have different types of filtration loops. You can have an offline filtration loop, or even inline. You can have a suction, a pressure, or a return filter. So all of these have different pros and cons, depends on the system, but you really want to make sure it's sized to fit the system and sized to get you down to the cleanliness code that you need. You can do that by adding in just different offline loops to keep polishing that fluid as needed. You can adjust your filter media construction. So going from like a paper media to a paper media or cellulose up to a fiber media can improve your filtration and your filtration efficiency. And you can also adjust your filter media grade. So rather than attempting to filter out the 20 micron sizes, you can bump it down to that 5 micron or even 2 micron, depending on the filter you need. So before I jump into contamination, I know we have the chat, or you can raise your hand, but I just want to make sure there's no questions before we move on from particulate. It's really the most common. I just want to make sure we're all on the same page and there's no pressing issues before we continue.
The chat looks pretty clear right now, Brad.
Okay, perfect. Yep, looks good. So we'll go ahead and dive into the water contamination here. So back to the basics again, just like we started with the particulate contamination. There's two types of water contamination in hydraulic systems. So you can have dissolved water and free water in your system. So the dissolved water, it's when the water content is below the saturation point of the oil and you can't visually see the mixture. So if you think of it as adding salt to water, before you get to that saturation point, the salt is just going to dissolve into the water. You won't be able to see it's there, but it is still present. It's a very similar comparison to the water dissolved in the oil here. It's still present. It can still cause issues for certain applications, but it's not visually detectable in your solution. Free water, on the other hand, is above that saturation point. So as you can see down here on the bottom right, it turns into this nice cloudy mixture when it's all combined, but it does generally separate into a separate layer. So if you let the system sit, if you're not running it for a given time, it'll separate into that distinct oil and water mixture that I'm sure everyone's seen before. And this free water is a lot more problematic given that it changes those properties of the oil. So as you can see, these two samples look a lot different and they'll also perform a lot different. That water will change the viscosity of your oil. It'll change a lot of the lubrication properties, and it can accelerate some breakdown within your system. So where does it come from? It can be similar to the particulate contamination. It can come from those worn actuator seals, and it can also come from reservoir openings. So if you see this picture on the right, if this isn't sealed off and only having the opening come through this breather, water can drip down into the system by just accumulating on top of the reservoir. It can also come from condensation. So if you have temperature changes in your environment, that air that enters the system can heat up and cool down, and that water will condense on the reservoir surfaces, and that can fall down into your oil and be introduced into the system that way. Another common one we see is heat exchanger leakage. So if your system has a water heat exchanger to cool down your oil as it runs through the system, a leak may start there, and that water will enter into the oil stream and can build up until it gets to that free water tipping point. Again, what can this water contamination do to the system? So the water can enter in your system and cause corrosion of metal surfaces. It can accelerate that abrasive wear. That comes from the decreased lubricity that you can see in the oil. So that water is not going to be as slippery. It's not going to lubricate the internal moving parts as well as the oil will. So those metal parts may rub together and break off into more particulate contamination. Bearings in the system can also be broken down in a similar way, just by not being as lubricated as they need to be. Different fluid additives can break down. So all oils pretty much have an additive package within them. And this water can enter in there and break down some of those properties. Again, the viscosity can change, so that can affect the performance. It can affect the pressure drop you see within a system. And it can also increase your electrical conductivity. That's something that's a little bit more specialized, different applications. But if you do see that electrical conductivity rising, it's usually attributed to water. One thing I wanted to dive into here, so I've kind of touched on it a few times, but mechanical equipment and water don't mix very well. So as you start, you can have, if you start here with 5,000 ppm in your system and you get rid of some of that water, you decrease that parts per million down closer to the saturation point. So this 450 that you drop it down to is still above the saturation point of most oils. So you'll still have free water present, but you have decreased it by a lot. If you look past that, that would give you a 4 times increase in your mechanical equipment life. So just by dropping it down, you still even have free water. So you could even go further and further the cleaner you go, but the mechanical equipment will last 4 times longer just by decreasing that water parts per million from 5,000 to 450. So that's just something to kind of bring it back to real life. What does this water contamination actually do? It really just breaks down your equipment way faster than it should be. It can cause, again, a lot of costly replacements and maintenance attention. So how do you prevent this water contamination from entering? It's a lot more cost effective to keep the water out of a system rather than try to get it out once it's already present. So you start by using similar prevention methods as we did with particulate contamination. So rather than just the traditional air breathers, you can use the desiccant air breathers. So these will filter out the particulate from that air as well as water that comes with that air. So there's always water present in the air in our environment. This desiccant will absorb that water before it enters your system, and it'll introduce clean, dry air to that reservoir. Again, you can also flush all your systems before initial startup. Before you introduce your oil, there could be buildup, could be condensation within there that you want to get rid of before you bring it up to pressure. You, again, specify rod wipers and actuator seals. Just like particulate, water can build up on those exposed surfaces, and you don't want to bring that back into the system. And you can also cap off hoses and manifolds again whenever you're handling or doing maintenance of those. Just like with particulate, that water is in the environment, can't keep it out if there's no cap on those hoses or manifolds. So now going into some of the detection methods of water contamination. So it's a little bit different than particulate contamination just because it's not a hard particle. You can't see a shadow from the water. So the first thing you can do is do a visual inspection. So if you take a sample of your oil and it has this cloudy mixture, that cloudy substance, cloudy look to it, that's a dead giveaway that you have water contamination in your system. Also, if you take a sample, you're not really sure if there's water contamination or not. If you let it sit, and then it'll separate out into different layers if there is water present. You can again use lab testing. Like I mentioned before, the lab testing can tell you anything and everything you could possibly want to know about your oil sample. And then there's also relative humidity and water content sensors. If you want the fluid to stay in the system, you need constant uptime water content readings. You can utilize those so you don't have to take samples. You don't have to turn the machine off to get any separation of that fluid. And again, it does vary by application, fluid, and data requirements. So it's kind of a case-by-case basis what's going to be best for you. And again, myself or anyone from the RG group is more than willing to help out if you do have a water contamination problem in any systems. So to fix excessive water contamination, so once we've looked at it, we know that there is water present in the system, and you know you need to do something about it. The first thing you could do, if you can afford to not use the machine for a little while, you can turn the machine off, let the reservoir settle, let that oil and water mixture separate, and then you can drain off the water layer of that mixture. That's probably if you're not using the machine 24/7, it can be the most cost effective. It's very effective method of getting rid of the water. But again, not everyone can turn off the machine and let that reservoir sit. Beyond that, there are various technologies on the market for a system that needs to always be running, needs to constantly be in use. You can use absorption media. So rather than a typical filter that only pulls out particulate, the absorption media will absorb that water present in the fluid. So you can see here before it absorbs that water and after it puffs up and just pulls that water out of the solution. And then you can also use vacuum dehydration. So this will essentially lower the boiling point of the water in the system by decreasing the pressure. And it will basically just boil off that water from the system. So these are just two examples of Parker units that we have with that technology. And then there's also centrifuge machines out on the market that Parker doesn't have, but what it does, it essentially spins the oil really fast, and the density difference causes that water to leave the solution and exit that oil. So these are just a couple of different ways to fix it. Again, depends on how much water you have, what you need to see from your, what you want to see from the fix, and different restraints within your system. So from what I could tell, the chat is still pretty clear. I'm not sure. I don't think anyone's raised their hand. I haven't seen that with a question.
No, I haven't seen that either, Brad.
Okay. All right. Sounds like everyone's on the same page here, and we'll jump right into air contamination next. So similar to water and particulate, there's different types of air contamination. There's a little bit more going on with the air in terms of how we classify it. But similar to water, there's free air and dissolved air. So free air is basically just considered a pocket of air trapped in the system. So where you expect there to be oil, there's just an air bubble or an air pocket within one of your pipes or in one of your components. There's also dissolved air, which is the exact same thing as dissolved water. It's just within the fluid. You can't tell it's there visually, but it is present. There's entrained air, which is just a ton of small bubbles all dispersed in the fluid. You can see over in this picture, these bubbles down here on the right, those would be entrained air. They're just in solution, little bubble pockets that travel around with the fluid. And then there's also foam, which is larger air bubbles that build up on the surface of the fluid. So these will typically stay in the reservoir unless you pull the fluid level down too far. But they are present in the reservoir, and it's easy to see those when you open up the reservoir. As far as where air contamination comes from, it can come from system leaks, just like water and particulate. It can come from pump aeration. So if your pump isn't seeing all the fluid it needs to, or isn't designed correctly, it can introduce air contamination that way. And you can also get it from reservoir fluid turbulence. So if you look at this picture on the right, you can see there's a bunch of splashing in this reservoir. The fluid's kind of going everywhere. That can pull air down into the solution and introduce that to your system. As far as what can air contamination cause within your hydraulic system, the main one that you can see is a loss of transmitted power. So rather than using that power to cause movement within your hydraulic system, the pressure will build up and compress these air bubbles individually before it will actually be able to move anything. So that will cause a spongy feel typically to a hydraulic system where you press forward on what you want to move, and it has to wait a little bit of time. There's a little bit of a lag as it's compressing all these air bubbles before it builds up the pressure to actually move the system. You can see a reduced pump output. Again, you can see a loss of lubrication. especially when the air is entrained in the system. It's dispersed throughout the fluid. It can decrease that oil viscosity and that oil lubrication properties. It can increase your operating temperature. So similar to how I said those bubbles need to be compressed before the pressure will build up in your system, that compression greatly increases the temperature of that air bubble, and that will leak out into the rest of the system and spike your fluid temperature, which can transfer into the different components and cause less than ideal operating conditions. The reservoir fluid can foam, and it can even get so bad that it may overflow from your reservoir and cause a mess everywhere, as well as that foaming can be pulled down into your system if it gets too bad. And there can even be chemical reactions within your system. So that air is present where it's not designed to be. That can mix with different metals, different additive properties within your fluid, and cause some different chemical reactions that you don't want to happen. To prevent air contamination, it's a little bit different than water and particulate, but really what you need to do is air bleed your system. So a lot of systems are designed with these in there. It can help get out that free air, those air pockets that may be present. You can also use a flooded suction pump so that it's not pulling in any air. It's not going to introduce that aeration into your system. If you design the reservoir correctly and have a filter or have a diffuser or your return line entering in correctly and not splashing around the reservoir, it'll decrease the amount of air contamination. And that diffuser, like you can see down here, rather than having all of the fluid mixing around all over the place, if you just have it nice little laminar flow lines, it'll decrease that air contamination. So as you can see, a little bit laid out down here, a little bit better. The laminar flow, there's not much room for air to be splashing around, introduced into the system. When you get this turbulent flow, there'll be splashing, there'll be air pulled down into the water or into the oil, and that can cause that entrained air and those air bubbles within your system. To detect air contamination, the main way to do it is visually. There's not a ton of products on the market that can test for air contamination just because it is easy to see visually, and that's the most cost-effective way to do it. So whether you look at a reservoir, if you look at a sample, you can see bubbles within the fluid, you can see them on top of the fluid. And one thing I want to point out on this picture on the right, depending on what type of sight glass or level reader you may have on your reservoir, you can see different things. So whether you have the bullseye just up at the top to tell you the level, that'll have the foaming come in. You can see the air contamination at the top. Or if you have a column type, you'll really only see where that fluid enters into the column. So just something to keep an eye out for. Remember, whichever one you have, it may not represent the entire reservoir, but it is just a little snapshot into there and can be helpful depending on what you're looking for. In order to fix air contamination, the best way and the cheapest way is just to let the system settle. If you can shut down and let it turn off, those bubbles will rise. Eventually the free air will separate from the system. You may have to redesign some system problems or some incorrect designs within the system. So if your reservoir is designed and it's splashing all over the place, the fluid's just being kind of dumped in, not entered into the bottom or within the fluid level, that can introduce aeration. So you may have to redesign that, or you can also use vacuum dehydration, which is the same method we use to get out the water from a system. Vacuum dehydration will also remove air contamination. And that's really in extreme cases where you're not able to do these other two options. Would you consider vacuum dehydration? So that is all of the information I have here today. So far, there haven't really been any questions or comments or anything like that, but I want to give time now just to dig into that, see if anything has come up since with air contamination, or if you've thought about anything with water, particulate, or really anything else within the hydraulic system. I'd love to help answer some questions.
Yeah, thanks, Brad. Appreciate it. So yeah, open it up to the group here. I mean, maybe there's a question that you had on your mind coming in that maybe wasn't addressed in the presentation. Oh wait, we just got one come in. It says heat. I was just wondering about heat.
Heat. Okay, yeah, so I think the main point, you'll see heat introduced into the system when we're talking about contamination. It can come from the air contamination being compressed down. That's one source where heat can be generated within the system. And it can also come from friction within the system. So if you have water or particulate within your system that can introduce extra friction, it can break down that lubricity of the oil and cause that to generate as you have moving parts. So I guess the starting point would just to be look at the system, see what contamination you have present. Sometimes the system's just the power and I guess design of the system will introduce heat naturally, in which case you may have to use coolers or anything like that. But if it's a new problem that wasn't there when the system was new, contamination can probably be to blame. So looking at those will be kind of your best guess on how to fix that problem.
Okay. He added a little bit to that. It says we have overheating issues sometimes. I'm thinking it's from shear in the valves and pumps, and also we're using food grade. Okay.
Yeah. So that could just be the design in those valves or pumps. If you're using food grade oil that's going to be super clean, I would just say that's probably just the way the system was designed. If contamination isn't an issue and you're aware that your fluid is very clean, it could just be you need a cooler or need something like that to maintain that operating temperature that you need.
Brian, we could probably reach out to you directly if you want us, after the fact, and have Brad answer some stuff, maybe take some photos for you and stuff like that. He can maybe help you out offline as well at the end of this. So maybe I'll give Brad, Brian, I'll give Brad your contact information, Jason, so maybe we can follow up through that.
Yep, absolutely. Thanks,
Brad.
Brad.
Yeah, definitely. Kind of like I said during the presentation as well, a lot of the stuff can be system specific, just in terms of what's occurring, what the best way to move forward is. So yeah, I'd love to go offline after this and learn a little bit more about what you do and see how we can help out.
Great. Any other questions? Give it a minute here. Yeah, so I started taking some notes. I was going to recap, but then, at the end of the day, I just couldn't keep up. You kept bringing up some excellent points there, but, a couple of things that, and I've been doing this a long time, dealing with hydraulic systems and whatnot. And the cleanliness of the fluid is just so important. And I think it's one of those things that we take for granted. Right. And so, knowing that when you mentioned that new oil is not usually clean enough for the components, our hydraulic components, I think that's one that probably surprises most of us. You would think you're buying new oil, it should be clean, but that's not the case. And then the other one is that, we often look at the fluid when we take a sample, but the reality is that the size of contamination that can damage the system is not visible to the eye. So when we see something in there, we're like, well, it looks, for the most part, it looks pretty clean. It's all the things that we don't see in there that can really do the damage. And again, you went into the water and the air contamination as well. But, a couple of your slides, you mentioned the testing. And I think you showed the little plastic bottle. Parker Hannifin has the test kits. We have them at our 8 retail locations in our geography, but you can also just, call us, call me, call our customer service team, and we can send you one of those kits to have them tested. So that's something that, may be a good starting point if anybody on the call are having some issues or think they're having some issues, and maybe they're not, but they just want to make sure they're not. So it's always good to have your oil tested. Let's see, I don't see anything else coming in from the chat.
Yeah. So I guess one shameless sales pitch we can say is, RG Group obviously can help you out with a lot of these issues. If you just need someone to bounce ideas off of, obviously we can be there for you. If you actually want someone to come in and actually do the checking, we have offer preventative maintenance programs. We actually can come in and actually clean your oils as well. there's lots of options, but you know, at the worst, just call and ask. You know, it couldn't hurt to bounce ideas off. So these guys are available for you at any point. So.
Yeah, and we do have a field team. You also mentioned on a couple of your slides, you know, flushing the systems. You know, we do have a team really specifically for that purpose that can travel all over the country, in fact, doing, you know, large installs and flushing and things of that nature. So you may not have known RG Group for that, but we do have that service available. So again, anything we can help you with, please reach out. We'd be happy to help.
Great. Well, thanks everybody. Hey, thanks for staying on for such a long time as well. I have recorded this. We'll follow up with everybody after the fact, so you'll have a chance to review this recording if you want to share it and everything else. But again, thanks for your time.
Hey, Ben, one other thing, sorry to interrupt, but we will be sending a survey out afterwards. So we would really appreciate your feedback. Like I said, we have this is the first virtual one of these that we've done on contamination, but we've done the hydraulic safety works as well. So we're always looking for ways to get better and you know, bring you guys valuable information to help you, you know, keep your operations up and running, lower costs and more uptime. So please take a few minutes and fill out the survey. That's all I got, Ben. Thanks.
That's
Thanks,
good. Hey, everybody. Thanks for your day. I hope you have a rest of the good day for the rest of the day. All right. Take care now.
All right. Take care, everybody. Thanks,
Thank
Brad.
you, everyone.